Hello, welcome to session 21, EMP protection in underground shelters. Steel structures like this are not automatically EMP shielded because they're made out of steel. Every point of entry, every pipe, every electrical penetration, every penetration in here, including the entranceway or the emergency escape, has to have an EMP shield or an EMP waveguide. And when I'm talking about EMP shield, I am talking about EMP shielding to mil-spec 188, 125. That is the only mil-spec out there. That's the only spec, that's the world spec for protecting against electromagnetic pulse, which is a nuclear weapon that's usually detonated 20, 30, 40 miles above ground, and in the case of the US, centrally located, which would knock out all the power in the United States for a long time. EMP is divided into two types of damage. There's grid damage. If you're connected to the grid, it takes at least a mile of these lines to generate power to go back into your house or back into your shelter and damage what's connected to it. But there's also direct damage, which means it's not connected to anything, but it isn't shielded, and this particular unit with electronics is not connected to anything other than the equipment in the shelter, and it can get damaged directly, even if you have a steel shelter. What's vulnerable to EMP? Solar panels, because they're a bunch of microprocessors, so they're very vulnerable. Although, for maintaining batteries, you can put up a solar panel after an EMP event to maintain the charge in a battery bank. City water, all the pumps, everything is connected by a lot of equipment that are controlled by circuits, computerized circuits. Charge controllers are full of electronic circuits vulnerable to EMP. Most electric ovens and some gas ovens have units in here that are electronically controlled. But you can buy gas ovens, by the way, that are electronic free. Refrigerators have electronics. There are some that are electronics free that are gas powered. And HVAC controllers have printed circuit boards in them. And now the newest thing, of course, is the lithium batteries that have micro circuits in them. So batteries are safe from EMP as long as they're lead acid or AGM. The solar panel controller is not safe, but the batteries, because there's no circuitry, is safe from EMP. Now the EMP pulse is actually 3 components, and that's what makes it so bad. You've got a 1, 2, 3 punch. The high frequency is 1 megahertz to a gigahertz, a billionth of a second, and surge protectors can't react fast enough to that. The second phase is the medium phase, which is like lightning, and it's a few millionths of a second. The third phase is the low frequency, 3 hertz to 30 hertz, followed by an E2 wave, which is a few thousandths of a second. But the triple punch is what makes it so damaging. Now there's, depending on the equipment and all kinds of factors, there's operational upset that can knock out a controller, for example, for maybe 24 hours, but it comes back. Then there's functional damage, and they are just burned out forever. The least susceptible are transformers, brushless or traditional electric motors, some heavy-duty relays, and circuit breakers. Partially susceptible vacuum tube equipment, some alarms, some panel indicators, some process control, and virtually all computers or any equipment with chips. Long cables over a mile collect EMP. And if you're buying equipment, you can ask for anything in the equipment that is EMP susceptible. Transfer switches typically have a 1/16 gap between contacts, and the arc can from the EMP can jump across a little over 1/4 of an inch. So if you want to have a transfer switch, you have to have them specially made up. And you can have them specially made up by only 2 manufacturers, and they have switches that have a 1/2 inch gap, so you can switch from grid power to generator power. Or you can set your circuit breaker panel up so you have a 400 amp and you simply plug one in the other. This still meets the code, by the way, because you can't plug them in at the same time. So it's still legal protection to use. The mill standard 188, 125A, and now they're up to C, which is the high altitude electromagnetic pulse HEMP for ground-based facilities, for time urgent and critical facilities. But here's the golden rule, and the military always follows it. You don't use the shelter as an EMP shield, and you don't use the EMP shield as a shelter. And what that means is you don't make the shelter into an EMP shield. It's too complicated, it's too expensive, and it's too hard to do. You can't depend on it. But you can shield each individual unit. You can shield the generator. You can shield the inverter. You can shield the solar panel controller. So you can do that. If you want to make the whole shelter EMP shielded, it really gets complicated, because the gasket all around here where the entranceway connects, that's got to be an EMP shielded gasket, and you have to bind it with a neoprene gasket to keep the water out. Anything incoming air, wherever these connections are, that has to be EMP shielded. Anything over here, EMP shielded. The problem is a lot of people use neoprene gaskets. Neoprene gaskets and EMP shielding do not go together. You have to use an EMP shielded gasket that has the right ratings on it at the right decibel level. But anything coming into your power line, water line, solar power line, radio cable, all POEs have to be EMP shielded if you're trying to make the shelter itself EMP shielded, which is not the way to do it. This is the EMP shield graph from Mil-Spec 188 125, and it tells you what the decibel shielding effectiveness is required here, and that depends on the frequencies that are here. So all these have to be shielded to certain specified levels here, and that means it meets the spec of the Mil-Spec 188 125. And just as a reference point, here are some of the frequencies down here for UHF, federal government, VHF, FM, CB, so you can see where they are. But here's the required minimum shielding effectiveness in decibels for each of these frequencies, whether it's magnetic, electric, and plane wave. Here's the minimum shielding. The decibel scale is used because it's a logarithmic scale. There's no sound involved here. It's just as that scale. The efficiency of the shielding is based on that decibel. 20 decibels is 99% effective. 80 decibels is 99. And look at this, 99.99999. And one frequency in that EMP shield has to be 99 out to 6 places here. Pretty tough to do. EMP shielded gaskets. The gasket that goes around these hatches are almost always some type of rubber, neoprene, EPDM, something, and that is invisible. If the gasket is a 1/4 inch thick, that's a 1/4 inch gap is how the EMP wave sees that. All the EMP frequencies just see the gap because it goes right through the rubber or plastic. Aluminum is a great EMP enclosure, much better than steel. This is a 14 kilowatt inside an EMP enclosure. Down here you can see the EMP shielded waveguide. That meets all the specs. Anything that is coming in here, all these have an EMP gasket on it. Any wire that's coming in has to be wrapped in a certain way, in a 90 or 180 degree bend. Anything coming out of here on the exhaust is another waveguide up here. So, and you can basically test it by putting a radio and your cell phone in there and closing it up and see if you can hear it ringing. This is an EMP enclosure in a composite hull. So we didn't shield the whole hull. We shield the generator. As the air comes in, there's a waveguide here that meets the EMP spec for the decibels and the frequency. There's another EMP shield when the exhaust air goes out. So these EMP guides, these waveguides, allow the air to penetrate, but not the EMP frequencies. And then all around here is an EMP gasket that is not rubber. You can see it a little better here. For inverter chargers, they're full of electronics. They're really vulnerable to EMP, even down in a shelter, even a steel shelter. So there's an EMP gasket all the way around here, and they're pretty expensive. A gasket like this is about $150. And there's a gasket on the cover on anything that goes around here. Here's an EMP waveguide. There's a gasket around there. So all this has to be EMP shielded. This generates a lot of heat. So there's fresh air coming up here, EMP shielded. There's hot air going out through the top, EMP shielded. So all the penetrations have to be EMP shielded. And here's why aluminum is such a good EMP shield. The conductivity of these of steel and aluminum and copper are very different. Copper's the best, but you don't need it that good. 7 million sieverts is actually marginal. Aluminum is the best thing to make EMP shielded box out of. And here's some of the test frequencies for EMP testing. You can't usually test the intensity like it would be from an EMP, but you can test the frequency. So you can test these frequencies. You can put the AM, FM radio in there. You can put your cell phone in there, and you can see if you get reception, see if you hear it ring. It's a rough test. Just remember, we don't have the million volts that an EMP burst would have, but we can simulate the actual frequency.